Hi everyone. Now we are going to discuss about applications of Gauss's law. Field due to an uniformly charged shell. So to find the field due to uniformly charged shell, we can use Gauss's theorem. Consider a charged shell of radius r. Its charge density is sigma and we are considering a point P outside the shell. So it is the shell which is having charge q. The radius of the shell is r and this is the point outside the shell. This is the point outside the shell, and for finding the field due to this shell, we need to consider a Gaussian surface. We are considering a spherical Gaussian surface here. So this is the spherical Gaussian surface. The radius of the surface is r, small letter r, and we are considering a small area delta s. Consider a spherical Gaussian surface of radius r passing through P. Consider a small area delta s on the Gaussian surface. According to Gauss's law, we have the equation delta phi equal to 1 by epsilon 0 into delta q. This delta phi we can write E dot delta s equal to 1 by epsilon 0 into delta q. The angle between E and delta s is 0. So if we are taking dot product E into delta s cos theta, the cos 0 will be 1. Then we can write E into delta s equal to delta q upon epsilon 0. Now we are going to find the expression for electric field outside the shell. So point on the Gaussian surface. Now the point is on the Gaussian surface. This is the Gaussian surface and P is the point which is on the Gaussian surface. Integral E into delta s equal to q upon epsilon 0. No need to consider that cos theta because the angle between E and delta s is 0. So cos 0 will be 1, and when we are integrating this q, it was delta q, now it is q. When we are integrating, we can write q because integral delta q is equal to q, and epsilon 0 is a constant, we cannot integrate it, we are taking it outside. So it will be integral E into delta s equal to q upon epsilon 0. We are integrating, that is the reason for the change of delta q to q. Then we are taking E outside. E into delta s equal to q upon epsilon 0. Now we are considering integral delta s. Delta s is the small area. This is the delta s. When we are integrating delta s, we will get entire surface area. The radius of this surface, the radius of this spherical surface is r, and the entire surface area will become 4 pi r square. So we can write E into 4 pi r square is equal to q upon epsilon 0. Now we are changing the value of q. Q is equal to sigma a. So we can write E into 4 pi r square equal to sigma a upon epsilon 0. Then A is the area of the shell. So the expression for A is 4 pi r square. So we can write E into 4 pi r square equal to sigma into 4 pi r square upon epsilon 0. This 4 pi and 4 pi will cancel each other. Then we can write E into r square is equal to sigma r square upon epsilon 0. Then expression for E will be E equal to sigma by epsilon 0 r square by r square. Now this point is on the surface of the shell. So point on the shell surface. If the point is on the surface of charged object, the final equation was E is equal to sigma by epsilon 0 r square by r square. If the point is here, we can write r equal to r. So the equation become E is equal to sigma by epsilon 0 r square by r square. They will cancel each other, then E is equal to sigma by epsilon 0.